Let me share my screen. Are you going to do any intro or anything like that?
Hello everyone, and welcome to another virtual meeting for the CentralOhio.net Developers Group. I am Alan Barber. I'll be your host for the evening. In case you haven't noticed, I am not Matthew Groves, who normally runs these. He had other activities for the evening, so I had to take over. Sorry about that. So just wanted to thank everyone for figuring out that we're over here on YouTube now as opposed to Twitch. Hopefully everything will run smoothly tonight. This is my first time trying to do one of these streams, so bear with us if we have any technical difficulties or things get a little crazy. With that said, I want to say welcome to any new people that have checked us out for the first time. We are the CentralOhio.net Developers Group. We're based out of Columbus, Ohio, or all of Central Ohio, really. We do all types of .NET and Microsoft-related technology stack discussions, topics. We meet the fourth Thursday of every month. Since COVID kicked in, we had to switch over to being virtual. We're hoping to get back into the real world here pretty soon. So we'll have some more details on that in the next coming weeks, probably, as we kind of get some things lined up. So exciting things to come. We got a few short slide decks to go through, and then we'll get jumping right into the topic. Looks like we're up to, hey, we got some, I should check the chat here, shouldn't I? So hello to Kurt and Kyle and Marty and Matt and Demu and Pat and Kim. Thanks for stopping in and checking us out. So let's get this slide deck going. So as always, we have a website. Well, we used to have a website, now it just redirects to Meetup. But we have Twitter, we have Facebook. We invite you to follow these, sign up at Meetup. We want to make sure that you get the latest information about all of our upcoming events, as always. So that's sort of a important thing. There it goes. The slide deck got locked up. So anyways, please sign up if you haven't to follow. It's the only way you're going to know when the next event is. Hey, we're actually on YouTube this time, but we do have the YouTube channel. We'd like to try to get a few more subscribers on there. I believe we're currently in the mid-60s. I have to double check, but the belief is I think once you hit 100 subscribers, you can have a custom URL as opposed to the really long whatever random text is on that one. But we do have a bit.ly CONDG YouTube as well to check out. And our raffle sponsors. So we have we have a single JetBrains license to give away tonight, and there should be some Couchbase swag. We're going to try something new. There's a Google form. There's a Scan Me link. I'll share that link in the chat as well. Fill out your name and email address, and then we'll, at the end of the event tonight here, we'll do a random drawing of everyone that signed up, and we'll get you one of these prizes handed out to you. So that's it's any JetBrains license. It's a license or coupon code for 100% off any of their products. So that's a good one, and whatever Couchbase stuff, we'll have to find out what Matt Groves has. There's some other user groups in town that we like to make a shout out to. There's the Azure group, the Co-Azure. They meet the second Monday of every month. I just checked today, and they have announced that they are going back to in-person meetings starting next month. So they'll be back at the Microsoft office on the second Monday of every month. So any Azure specific topics you are interested in seeing, you should go visit them. Make sure to check out their meetup and website as well to get the latest information. But I did notice that they specifically mentioned they would be back in person next month. The Columbus App Dev User Group is another group in town that we have, and they meet the third Monday of every month. Currently, it looks like they're still online. They haven't announced anything that I can see for when they'll be back into in person, but hopefully they'll be like us and get back there pretty soon so we can all start hanging out together. And I'm sure you guys all miss the Donato's pizza that everyone has at every user group. There's also CBus Data, which used to be known as CBus Pass. If you haven't kept up on the loop on that, Pass, the Professional Association for SQL Server, they sort of shut down, but there's a process in works of kind of booting it back up, I know, but for right now, they've kind of renamed themselves to just be CBus Data, so it's the Central Ohio Microsoft Data Platform User Group. Oh geez, there goes my doorbell. They meet the second Thursday of every month, and as they as well are meeting in person again next month at IGS Energy, which is over in Dublin. So please check out them for all of your Microsoft Data Platform based needs. Here's sort of a quick rundown on our future meeting calendar. Next month we have Roger Hedgepeth, sorry, can't read. You'll be doing some .NET 6, Maui, and the future of Xamarin, so that should be really exciting. If you haven't heard anything on Maui, it's all about the new user interface that's multi-platform, and it's pretty awesome. September, we're still looking to fill a slot for there, and October we have Chris Woodruff, or better known as Woody, who will be doing an entity framework talk about, I'll double check what it's on, sorry. I don't have all my details on hand. And then that sort of wraps up our normal year. We'll be moving on then to November and December, which apparently that got misspelled as Dev. We usually have a in-person holiday party, which we'll try to have again this year. It's usually the first or second week of December. So that'll be a good way to kind of wrap up the year and for us all to get together. And then we're moving into the next year. We already have January lined up. Aaron Petrie will be doing a clean code and refactoring talk. And then the rest of the year is wide open. So we're sort of hoping you can help us out. If you see any good presentations online at other places, if you go to other user groups, you go to conferences. I know some conferences will be starting back up at the beginning of the year. Hopefully the things like Code Mesh will be back up and running in real life again. So, let us know if there's a great talk that you think they would be a wonderful person to bring in and share with the rest of the users here. And sort of speaking of that, there's some meeting topics and suggest a speaker. Again, if there's any topics, suggestions of speakers that you think would be a good fit for us, please, by all means, let us know and we can get them hopefully booked and on the roster. And as always, we're always trying to help out everyone, so if you work for a company that's hiring, feel free to post in the chat. If you're looking for work, feel free to post in the chat as well, but if you want to be a little more discreet and you want to get the word out to some people that you're looking to get a new job, Matt Groves has graciously offered the last couple months to just feel free to email him and he can make some connections on your behalf. You can feel free to email me as well. I can share my email. Company I work for, we're always hiring. And finally, we're always looking for more help on the team. There's just a small group of us that help work together every month to get this thing up and running. We're always looking for more help. People come and go as things shift around. So there's Matthew Groves, myself, Alan Barber, and Matt Ellen, and we'd love to add your name to the list if you're interested in helping out. A little bit of everything from just helping us find speakers, helping us plan the events, at the events just helping logistics of setting up tables and getting the food set up, things like that. It's not a lot of work, maybe an hour or two a month at most. So if it's something you feel you could be interested in to try to grow yourself, hey, that's all for that. And so that kind of wraps up everything. So tonight's presentation is Sean White with modeling missing data and the maybe MOAD. Let me get him up on the screen. There we go. There he is. Hold on here. I got to turn his audio back on. All right. Say hello.
Can you hear me now?
All right. Get an audio check, everyone. Anything?
Does it sound good?
All right. I think that's good. I got some thumbs up.
Cool. Okay, let me share my screen. And I apologize in advance for the wide aspect ratio, but hopefully I have things zoomed in enough that everyone will be able to read what's on the screen. Okay, I think I'm all set. Okay, so tonight we're going to talk about modeling missing data in your applications using a couple different technologies, patterns, nullable reference types, the null object pattern, and the maybe monad. So hi, my name's Sean Wright. Here's some information about me on the internet. I work for WiredViews. We're a digital marketing agency, web development agency in Northeast Ohio. I'm a co-founder of Craft Brewing Business, which is a B2B publication for the craft brewing industry. And I'm an MVP of Kentico Xperience. So to start out, we're going to look at a call to action in Kentico Xperience. So what is Kentico Xperience? It's a digital experience platform. And if you aren't familiar with what that acronym means, it's really just a CMS with lots of marketing features on top. It's kind of like an all-in-one solution for a web platform. It's going to be your site. It's going to be analytics and marketing. It's going to be consumer chases, product catalogs, all that stuff. It's built on ASP.NET Core, classic ASP.NET, and SQL Server. The classic part of ASP.NET is being rebuilt right now. And so sometime next year, the entire solution is going to be SQL Server and ASP.NET Core. And if you want to learn more about Xperience as a product, you can go to xperience.io. So if we were to look at Kentico Xperience, what is it? Here is the kind of demo application that you get if you create a new Kentico Xperience application. You're a developer, you want to work on it and build some things. This is the demo app. And it looks just like a normal website because that's what it is. It's a content management system that helps you create websites with dynamic content. And if we look down here at the bottom, we have a call to action. There's an image, there's a link, it's a button. If we click it, it'll take us to the store. Okay, cool. Where does this information come from? So let's take a look at the administration side of the application. And here we can see there is a content tree, and this content tree has nodes, and those nodes represent pages or information. Here we can see the homepage. We can kind of preview it here, and you can see there's UX that we can interact with. And we can change the look and feel of the content that's on the page here interactively, and also change the source of that content. If I scroll down to the bottom where that call to action is, you can see there's no interactive parts right here. And that's because this content is not hard coded, it's dynamic, but the source of that content and kind of how it's displayed, that is hard coded in a ASP.NET Core Razor view. So where is that content coming from? Well, if we look under the homepage, there's this CTAs folder, and there's this buy some coffee page. And if I click on that, yep, that's fine. We can see here's some fields, and these fields should match up with what we are seeing on the website. So the label here, buy some coffee, it's a link to the store page, and then here we have an image. And if we're looking at this content in this form, we see buy some coffee. Here's a page that we're linking to, the store page. and we have an image that we're going to be displaying, and then some alt text too. Okay, so here's all the content. This is kind of a normal type of thing that you would see in a CMS, structured content that gets displayed on a page with some special design. And we're specifically going to be looking at how we take content or data that is optional or potentially missing and model that effectively in C#, because this is an ASP.NET Core app. So we're likely writing C# code, and we want that C# code to match the data that content managers or marketing professionals are coming and entering into this UI. You can see here that I can toggle this has image checkbox on and off. So I could, as a content manager, say this call to action has an image and this other one does not. I could have this box checked, but I could also have no value in here. So you could consider this maybe optional data or potentially missing data. And we don't want our application to crash or have some sort of unexpected presentation when that data is in various states of being not being there, either intentionally or unintentionally. So let's go back to the slides. And so how would we model this call to action in code? Well, we have the label, we have a link URL that's potentially missing, and I'll touch on why that would potentially be missing when we go to display it on the page. There's the has image Boolean field. There's an image URL, which is optional because we can toggle this image off, and the alt text is optional. And the CTA itself, the call to action, it might also be missing because a content manager could come in here and delete this page in the content tree. There's nothing that stops them. That might be normal content management experience that they would expect. They should be able to come in here and delete some pages and create new ones. And we don't want the application to crash if something isn't there. There's lots of different ways to handle that, but we're going to be looking at very specific ones that I find are generally effective at doing things like preventing null reference exceptions. So if we were to create a C# model type that represented this data, we might create something like this, a record type. Records are cool. They're great for transferring data from one part of the application to another, especially if there's no unique behavior that they need to have. So we might have a label, a link URL, whether or not the call to action has an image, the image URL, and alt text. Now, right now, this data or this shape of this type does not accurately reflect that any of these pieces of information might be missing or are optional. It's kind of telling us that this is going to be there. And that's not quite honest. And we might have expectations with how we write code that is creating this call to action or that consumes it that will fail at runtime because of those differences in expectation compared to reality. I have an issue with this record and how it's currently formed in that the has image Boolean field, it's not concretely tied to the state of the image URL or image alt text. So as a content manager, I could come in here, I could check this box, and I could enter some data in here. And then maybe I save it and I decide, oh, wait, no, I actually don't want to display the image. But the fields are still there. So the image URL and alt text are still saved in the database, but the has image flag has now been turned off. So has image doesn't reflect whether or not a value is actually in the image URL. So these things are kind of disconnected. It would be great if we could connect these things and also represent the possibilities that this data could be in. And this is a very simple example, but in content management systems and digital experience platforms, it's very common to have to model complex data relationships or data structures and do it accurately, because this data tends to flow throughout the application. It might be displayed on 20 different pages. It might have data that can be overridden by content managers. So we want to try and be as accurate as possible in the way we write our code to model this data. And this doesn't apply to just a content management system. This could apply to a line of business app working with some enterprise data set. You're going to be getting data from all over the place, and you have no guarantees about the quality of that data if fields are there or if they aren't. And we try to as developers, we want to get rid of nulls. We want to get rid of values that could be integers or strings, and we don't know. We want to make that stuff consistent and consolidate it. And so we need tools and practices to help us manage the complexity of that data. So how do we do this in C# specifically? So the first way that I'm going to propose we would do this is with nullable reference types. So if we want to turn on or enable nullable reference types in our .NET applications, C# specifically, we would add this nullable property to the CS_proj file. And we could potentially also add this warning as errors property. It would prevent compilation if null cases aren't handled. This could be good for a greenfield app, probably harder to turn on for an established application that hasn't had nullable reference types enabled. And if we want to use this feature in our C# code, we're going to add a question mark immediately after the reference type that we want to annotate as potentially being nullable. So if we're creating a variable, it's going to look like this. And if we have a property on a class or a record, it's going to look like this. So let's jump over to some code. All right. So if we look down here, we have that record that we looked at before that has a very simple type shape, and it's not really accounting for that missing data. We would like to maybe add nullable reference types to this and see where that can get us. So I'm going to jump over to where I have that already completed. And that's fine. And we will tell OmniSharp to reevaluate. Okay. So let's look at the types that we have. So we have this home index view model, and that's going to be like the view model for the page. And the call to action is one part of that parent view model. So the call to action view model, what do we have here? We have a label string, which makes sense because we have a label over here that's required. We have a link URL that's also required. That's always going to be present. We're going to see how we deal with that. And then we have an image, which is potentially null. The image itself has a URL and some alt text. And then the call to action on the home index view model is potentially nullable itself because Content Manager could come in here and delete this page. And so we want to be able to represent that accurately. So let's go up here and look at how we are getting this data. So we're, and there's some stuff in here that's specific to Kentico Xperience and data retrieval, but I wouldn't say try to figure out exactly what everything is doing behind the scenes, but just kind of follow along in the flow of how we would process this data. So we're going to get a call to action out of this repository, and we're going to use the home's path. So we're going to be specifically looking for call to actions underneath the home page because we could have call to actions throughout the site. So we're going to look for one, and this call to action you can see is typed as potentially null. So we need to check when we get that out of the data store. And if it is null, we're going to return null because the type that we're returning from this build CTA method is a nullable call to action view model. If that call to action happens to be there, then we're going to go and try to get the linked pages URL. And in Kentico Xperience, there's a process for this. The value that's actually stored here in this form when Content Manager selects to link a page to another page is going to be the GUID of the page. And that's because that GUID is going to be stable between multiple environments. So for synchronizing content between like testing and production, that GUID is going to be correct no matter what. So we're going to use the GUID of, let me scroll this over. So the call to action has fields, and one of them is the node GUID, and that's going to be this linked page. And we're going to say, find me a page in the tree, I don't know where it is, that has the node GUID that matches the one on our call to action. And then give me the first or default one that is found. And in the case of reference types, default is going to be null. And so if we look at this linked page, we can see it's a tree node, which means just some page here in the tree that is potentially null. So that means we need to, again, check. So we say is the link page null? If it is, we return null from here, because if we don't have a link, there's not much point in making a call to action that's going to be displayed. So we need both the call to action page to be in the tree. We need the link that it's referencing, the other page that it's referencing, to also exist. And then if those two things are true, we can move on to the next step, which is to get that linked page's URL. And so there's a Kentico Xperience has a bunch of APIs for doing this data access and retrieval. And we are going to retrieve that URL, and we are going to use its relative path. And we're going to use that to render out our call to action in our view. Now we address the issue of the call to action has image and image URL, potentially being in different states. So if we have an image and the image URL is populated, then we're going to create a call to action image type, an instance of that type, using the image and the alt text. Otherwise, we're going to populate that variable with null. And so if we look at this, again, it's a nullable type, and we're going to pass all this stuff into our view model and return that. And then back up here at the top in our home controller index method, we get our call to action view model, which is a nullable call to action view model type, and we're going to assign it. And then we're going to go to our view. So let's jump over there. And there's a whole bunch of stuff on this page to render out all this content, but we're specifically interested in this part at the bottom. So how would we use the nullable reference types? Well, we need to do we can do pattern matching. You can do equals null, but I like the pattern matching. I think it reads a little better. So we would say if the model call to action is an object, and we know that a value is there and it's not null. So in that case, let's start rendering out our call to action markup. Okay. Then we get to the image. So we know the call to action at this point is not null, but what about the image? Is the image null? And if it's not null, then we are going to render out the image. If it is null, because either the content manager unchecked the has image box, or because there is no value in the image URL field, none of this will be rendered. And we don't have to worry about potentially accessing a property on some null instance, which would throw that null reference exception, because we've put in place these guards and we've explicitly annotated our type to be nullable. And then down here, we'll display the link and the label. And we know that if we have a call to action, then both of these will be populated. Okay, so let me jump back to the slides. So what are the benefits of using null reference types to model missing or optional data? Well, C# requires us to check if the value exists, especially if you turn on those additional properties in the CS proj file. And there's quite a few that you can enable and toggle in different states to make it even more strict. But if you turn on all that strictness, then C# is going to not even compile if you are not doing checks to make sure that the values, properties that you are accessing are not null. That's a good thing, because we basically are going to remove null reference exception from our application doing this. So it's preventing the crash that we want to avoid based on the dynamic nature of this data. It has minimal impact to our model, which is good. So all we need to do was add that little question mark to the type. We didn't need to change the names of any of the properties. We didn't need to add any new properties or methods. We just added the question mark. We let the C# language functionality do a lot of the work for us. This enforces null checks on the entire model. So it doesn't matter how complex that model gets. If we have those question marks on those types, anytime we try to go and access those, even deeply nested ones, we're going to have those checks in place. And also, if we turn this on, we're really enabling null checks for the entire application. A bunch of the .NET framework at this point, .NET 5, .NET 6, has null reference type annotations, which means if we're using APIs like links first or default, it's going to return back a nullable type. And if we flip on that flag for nullable reference types, it's going to light up all the features and functionality that requires us to do those checks. So we kind of get this for free just by trying to model missing data accurately for a specific part of the custom code that we're writing. So what are the problems with nullable reference types in terms of modeling missing or optional data? Well, first of all, like I mentioned, it returns null too. Now that might not seem like a problem. That's probably a good thing, right? Unfortunately, this kind of shows how null has no domain specific meaning. So we have a call to action. This is a custom type we created. This view model is a custom shape type we created. And we're using the same low level language features for our types that the .NET framework is using for its types, and really just for anything that you would have in your application. These could be primitives, value types, or reference types. They could be built-in ones or they could be custom ones. So when we see a null value, does that mean that the data is optional or missing or broken? It's kind of hard to say because, again, this is a low-level language feature. It doesn't have any inherent meaning. It can't, because it wouldn't be very useful if it was specific to our application. So if a developer is coming into this code base and they see a repository returning a null value or a nullable reference type, and they do get nulled, should they put some code in there to throw an exception or log an error? It's kind of hard to say. There's nothing inherent about null that says this is the meaning of it for this part of the application or for this domain. And then we also have these kind of unergonomic checks and guards and fallbacks. So if we were to do more work here in the code, interacting with these types, potentially once we've already constructed this thing, if we were here to work with the CTA view model and wanted to access some of those properties like image and then its alt text, well, we got to do some checks here because it's potentially going to be null. So we're going to get this warning here, dereference of a possibly null reference. So we're going to end up with a whole bunch of if condition checks, or we're going to have a lot of these. And this, if you spread this throughout your entire application, it's going to become real hairy and ugly very quickly. And it becomes hard to read because each time you see this, you have to think, that thing is potentially null, it's potentially null. So it does work. However, I don't necessarily think it works great. That said, I think it should be enabled for all C# applications. So if you're creating a new greenfield app, turn on nullable reference types. They will help you. They're there for making your application better across the board, even if they aren't that great at this specific use case of modeling missing or optional data.
Hey, Sean.
Another
quick catch on you. We've had
yeah.
a couple people say the code's a little small to see, so if you could zoom in a little further on that.
Yeah, sure, no problem. I can actually, I'll make sure I spread this out. Is that better? I can go even bigger.
Let's see if that helps with everyone. How's that looking, guys? Looks larger to me, so.
Cool. If it's still too small, just let me know. Okay, so one more thing about the problems here is that nullable reference types aren't supported for .NET Standard 2.0. It's a C# 8 language feature. Requires .NET Standard 2.1 or I believe AS or .NET Core 3.1 or above. And because of that, if you still have to support classic .NET Framework and you want to share code between them, you are not going to be able to annotate those types with nullable reference annotations and have it work well. There's people that have explored getting it to work, and it requires a bunch of hacks, and yeah, it's just generally not supported. So what about something else? Let's try another thing. Let's try the null object pattern. So null object pattern, it treats null or empty as a special case of the model type. You can implement it with an abstract base class, private constructor, singleton, static property. There's lots of different patterns that you can find online of how to create a null object pattern. Generally, you refer to the null case, that special case, as is null or is empty. You create like a property on the type, and that's how you check to see if that thing is that special case. So let's jump back to the code, and we're going to jump over to the null object pattern, and let's scroll down here, and let's look at this code. Okay, so we're going to start out with our home index view model, that parent view model for the whole page, and we see that we don't have the null reference type annotations here anymore. That's because we don't need them. We're treating our types as always having a value of that type. It just might be that in specific situations, it's the empty value or the null value. So if we look here at our call to action view model, we can see that we still take in a label, a link URL, and a call to action image. But this type itself can be represented as empty. So there's a static singleton on the type itself that we assign when this type would be constructed at the startup of the app. And we can check, is it empty or is it not empty, by comparing the context of the instance to the empty instance. If they match, because this is a singleton, we know that it's the empty representation of this type. And we have to have a private constructor so that we can create an instance of this, but not let anyone outside of the type use that constructor to create that empty instance. So here you can see that we populate the fields or the properties we have on this type with some default values. In the case of string, it's just going to be an empty string. And in the case of the call to action image, it also has this pattern of the null object pattern where we are representing the missing optional data. It's not there. We'd normally do something with null if we were using null reference types. We're representing that as this empty instance. Okay, so if we go back up to our implementation of getting the data, how does this look? Well, it's going to look pretty similar to what we had with the null reference types, except instead of returning null, we kind of remove null from the application code, and we substitute it with the null or empty instances of our types. So in this case, again, we check to see, is the call to action there? Did the content manager delete the page? If they did, then we're going to return a call to action view model. It's just going to be the empty instance. And then we go and look for the page in the content tree that it links to. And if that's not there, then we're going to return, again, the call to action view model empty instance. Then we come down here and we do the same sort of checks where we're checking to see if the image is there and if the image URL has some value. And if it does, we create a call to action image. And if it doesn't, we use its empty instance. And then we populate the view model. And we come back up here, we get that view model, we populate the home index view model, we return that, and we're going to go to the view. And we're going to see that we do some very similar checks that we were doing with null reference types. So we're going to say, if the call to action is not empty, then proceed with rendering this markup. And if the image is not empty, then go ahead and proceed with rendering this markup. So this looks very similar, but we will see that there are different pros and cons with this when compared to null reference types. So I'm going to jump back over to the slides. Okay, so what are the benefits here? There is no chance of a null reference exception, right? Even if we somehow like miss a check, we are populating every property with a value. So we can deeply access as many things as we want without doing any checks, and we know we are not going to get a null reference exception. That to me seems like a good thing. We don't need to guard data access. This is pretty cool. We can just access whatever properties we want on any of our models, any of our types. We can pass any value we want to any method or service type or whatever. It's just going to work because we've guarded against it by making sure there's always a value, even if it is the empty values. We have an explicit representation of the missing or optional data for our application now. So we're not using the nullable reference type annotation for both the domain model that has specific business meaning to us and the low-level language features. So we could add more syntax or maybe change the language a bit on those implementations of the null object pattern to have more meaning to our code base. We have full control over that code. We can do whatever we want with it. And I feel that the checks for the empty special case are pretty readable. So if I jump back over to the code here, this is reading like a sentence, which is kind of nice. I'm not doing the pattern matching. If this thing is an object, then do this action. especially to a newer developer. They might read that and be a little confused. Why am I checking that it's an object? Here, it's pretty clear that if the call to action isn't empty, well, then yeah, I want to render it out. So I like the use of the language there. So the check in the view, that's a type of check that we are kind of not forced to make. And that check, it's going to appear on all the models that we need to turn into these null object pattern implementations. So every single type, and in this case we have, let's see, we have 1, 2 types here that we have had to handle that optional or missing data with and follow this pattern with. But if we have types all over the place for a large application, we're going to be following this pattern a lot, and we're going to be doing this type of implementation a lot. And now the model that's supposed to really represent the data has this extra stuff on it. So we're kind of polluting those models with the special case code so that we don't run into those problems that we were initially seeing. We need to keep that implementation consistent between all the types. You could maybe do that with an abstract base class or some interfaces or something. Unfortunately, we don't have static interfaces, at least not yet in C#. So this static property, which is a pretty common way of doing this implementation, there's no good way to enforce that empty always is the same spelling or the same word on all the types. Now, IntelliSense is going to, help you not typo something, but still, we really want consistency there. It's kind of hard to enforce. It doesn't handle value types well. So what if we have a string? When we have a string that maybe is empty, and we want to represent that as being empty, but not an empty string, how do we do that? There's no good way to kind of piece that apart. Whereas with a custom type, we can add, whatever methods or things that we need to give that empty or null behavior to it. So if we look at these values like 0, false, and the empty string, those are going to probably be the default values we use for primitives for value types. And yeah, there's no good way to differentiate whether or not it's intentionally false or false because it's supposed to represent data not being there. Another issue is that it's hard to transfer the empty state to a new type. So if we want to convert, let's say we have something, not view models, because those are kind of like at the end of the application stack. So we're getting ready to present the data and we aren't creating any more types or converting things. But if we have something that's in the core of our application and we're trying to use a null object pattern with it, and we want to convert that to a view model and it has an empty value, we need to make sure that the view model we're mapping to has the same sort of implementation. And then how do we have to do a check to make sure that we map empty of one over to empty of another and not just map the values over. Also, processing empty values might produce some weird results. So if you pass 0 to some data access method, what's that going to do? If we're using that as a default, that might happen a lot, especially if we forget to do a check and make sure we don't call that method if we have an empty instance of a type. So developers aren't forced to consider this empty case. It's good because it's maybe a bit better of a developer ergonomic experience. We don't have to have checks all over the place, but because we don't have to have those checks, we might be processing data that we don't intend to under other circumstances. So this solution was pretty popular before nullable reference types existed. I think it's still a fine solution, but it does have these problems with it. So what's the real solution that we're looking for? We want to represent missing and optional data with the type system because it's C#. We love the types that it provides us. So let's try to leverage that. We want to be able to access values without having checks all over the place. That also seems like a nice developer experience. We want a higher level representation of missing or optional data besides C# language features. So the nullable reference types is a bit too low level. We also don't want to have special case infrastructure inside the type, because that's going to pollute that model, and it's also going to be hard to keep consistent. So that brings us to the maybe monad. So what is a monad? And if you have flirted with functional programming concepts, you might have heard of a monad before. Maybe you've heard it as a joke. It's a pretty good joke when people joke about it. Here's a definition that I actually kind of like. It's a bit wordy, but I think once you see exactly what it is, if you're not familiar with it, this makes sense. So a monad is a design pattern that allows structuring programs generically while automating away boilerplate code needed by the program logic. So first, developers love design patterns, right? So we've in the first couple words, we've hit something that we can identify with. C# developers, we know the benefits of using generics. So awesome. So we have design patterns and generic code. And also we probably feel like we spend a lot of our working lives trying to get boilerplate code automated away, or boilerplate operations automated away. So this kind of checks all the boxes for us. A monad seems like a great thing to use. We just kind of have to figure out what it actually is and how to use it. So monads, yeah. Are you ready to use a monad? Don't worry, they're just containers. So C# developers, we already know what monads are. We probably just don't call them that. So task of T, that's a monad. Because task is a container of some data. It's a container that represents data that will be available at some point in the future, but it's still, you can put anything in it and you can perform operations on task, and you don't have to be concerned with what's inside to perform those operations. IEnumerable of T is another monad. We can do all sorts of operations on IEnumerable of T without having to know what's inside, or whether there is a value inside. We can just kind of define the operations and say, I'm assuming there's something in here, and if there is, here's what I want to do to it, but we don't actually have to know. And the maybe monad is going to work very similar to how these two monads work. So the maybe monad, what is it? It tells us whether or not a value exists or doesn't exist. It can be interacted with in either case. So we get to treat both the value is there and it's not there kind of the same. And then the maybe-ness of it, the value being null or missing or optional, it sticks with the data you're working with as you perform operations on it. So if you're converting a maybe of type string to a maybe of type int, the maybe part stays there, which is something that we didn't get with our null object pattern implementations, or at least we didn't get in a convenient way. So to give an example of what this looks like before we dive into the Kentico Xperience code, I have a small example in LinkPad. And I can zoom in here a little bit more. Okay, so we have an employee type that has first name, last name, email, and a manager. And that manager is an employee, but it's a maybe employee. So some people might not have managers. Maybe you're the CEO and no one manages you. But if you're low level, like an intern, then you probably have a manager and they have a manager and they have a manager, and you just keep going up. Okay. So let's create an employee and fill out their manager and specify that their manager actually doesn't have one. So maybe this person is the head of the company. So we get to populate the maybe manager field. It's a maybe of type employee with a new employee. So it's kind of nice here that we don't have to use any of the maybe stuff. There's a whole bunch of implicit conversions between maybe types and the original types that they contain that make working with them in C# kind of nice. And then here we get to explicitly specify that this employee has no manager. So the value this one gets is kind of like that null object pattern singleton. We're assigning it the value of none. It still has a value. It's just represented as the none case or the empty case. Okay, so if we're using the maybe type, here's an example of how we would get the senior manager's email address of a given intern. So we've created this intern. and we have access on the maybe type to these methods. It's going to look a lot like link because, again, IEnumerable of t is a monad. So all those link operations that we have on it are going to have analogs with the maybe monad that we're working with here. So the first thing we do is we call the bind method. And we take the employee that we have, which is the intern, and we're assuming that a value is there because we specified it as maybe. So, maybe there is no intern anymore, and this thing is actually maybe employee none. But we don't have to worry about that because we're working with the maybe type. We get to pretend that the data is there and just specify the operations we want to perform on that data. If it's not there, that's okay. None of these operations will be performed. But if the data is there at any point in this chain, then we'll continue operating on it. So bind says, I'm going to take the value that I'm working with and I'm going to map it, or it's kind of like select, to another maybe type. So this manager, we don't know if it's there. We don't want to get nested maybes. We don't want something that looks like maybe employee. And bind make sure that this thing gets unwrapped. And so we always will come back to one level of nesting. So we're going to say, give me this intern's manager, and then give me that manager employee's manager, and then give me their email address. And then if there's no value, because maybe there aren't any managers or even interns, then just specify or use the value unknown. We see the second method, map, and map is kind of like bind, but it maps the maybe value to some other type. So in this case, we have an employee and we are mapping to their email, which is type string. So the return type of this map is going to be a maybe of type string. So we've stayed inside the maybe. We've passed on that the fact that this data might not be there with what this method returns, and then we continue operating on it. And this last method, unwrap, says if there's a value that came from all these operations, return that. If there isn't a value, here, use this default. So if we are going to execute this, we can see that we end up with unknown because the manager here of this employee does not have a manager. So they're not going to have an email address. But if we remove one of these layers and execute again, we get, I don't know if you can see that, we get the manager's email address. And it was nice that we didn't have to do any special changes to this code to change the number of levels that we were checking. If we wanted to check and if we wanted to do like, a hierarchy really tall and see if that thing, that manager has a manager, we can just keep adding these bind calls and we don't have to change anything about our code. We don't have to do any checks against null reference exceptions, guards against that, checking if the thing's empty or not. We just get to specify the operations we want to perform on the data. And then at the very end, we say, okay, is there anything here? And if there is, we get that data. If there isn't, then we get some default. Okay, so let's jump over to the Kentico Xperience code. And we'll take a look at how maybe changes the way we implement our missing or optional data here. Okay, so let's take a look at our view models. Again, we have our home index view model. We've changed our call to action to be a maybe of call to action view model. So this is kind of like where we had our null reference annotation here. Instead of that, we are wrapping our type in maybe. So this should alert other developers that are looking at this code that this thing, if it's there, it's going to be this type, but it might not be there. So now if we look at our call to action view model, we again have our link, our label and our link, but our image is specified as a maybe of call to action image. So we've kind of replaced those null reference annotations with the maybe type. And in a way, we've combined the best features of both the null object pattern and nullable reference types. So how do we actually use this stuff in our code when we're getting data out of the database and we want to populate this home index view model? So let's scroll up here. And we could see that I'm in the index method. I was able to get rid of that private method that had all those early returns that were the, if this thing isn't there, I just want to get out. I want to bail out because I can't execute on it anymore. With the maybe type, we don't need to do that because the type itself supplies all the methods that let us interact with the data, assuming that it is available. So the maybe type itself handles bailing out early if the value isn't there. So we could see that the call to action, get call to action method on the repository now returns a task of maybe of call to action. So we unwrap the task, and then since it's a maybe that's being returned, or in this case, a task of maybe, we can bind to that, and we can say, okay, I have an async operation I want to perform. I want to get to the page that this call to action refers to. And you might say, well, you haven't checked to see if that call to action was deleted from the content tree. Well, I don't have to. The maybe represents the fact that it was not when this operation is executed. If the maybe that is being returned here has no value inside of it, this delegate that we're passing here will never be executed. So the type itself is doing kind of the traffic management and the checks of, is the thing here or is it not? And if it's here, then I want to proceed with these operations. Okay, so we get the pages out of the page retriever. We want to match up the call to actions node GUID with the page that we're looking for, and we get back an IEnumerable of tree node. And we're going to use another convenience extension method that you'll often see with maybe types, and this is called try first. It's very similar to first or default. The difference is try first will return a maybe of none of that type instead of null, where first or default would return null for a reference type. So we're saying I have a collection of pages. This is 0 to infinity of size. I want to try and get the first one. If there is there's nothing in this collection of pages, then give me maybe of type none of tree node, or maybe of type tree node with the none value. And if there is something in that collection of pages, I want to take that page and map it to a new type. And I'm going to map it to a tuple of my call to action that was passed in here and to the page that I just got out of the database. Since I'm returning a maybe of this tuple, I can call another maybe method on what's returned by bind. And so I'm going to get here a set, which is my tuple of my call to action and my linked page. And now I can perform more operations on it. And again, this map methods delegate will not be called if there was no value either in the pages that were returned for my link of the call to action or the call to action itself. So here I've handled those two cases where I was doing early returns with the null reference types and with the null object pattern. They're being handled internally by the maybe monad. So we come down here and we're going to create our image, and we say, if this call to action doesn't have an image, then go ahead and use maybe none. So we're specifying that there is no value here. If the call to action does have an image, we want to again check, is the image URL populated? If it is, then we are going to create our call to action image. If it's not, we're going to supply this placeholder. So here, we could have done this with our other implementations, but I thought it was just nice here to show that the call to action image and the maybe of call to action image are, there's implicit conversions between them. So we don't have to do anything special. Like we don't have to do, there's a maybe.from where you can create a maybe from some primitive type or any type that you have. We don't have to do that because of the implicit conversions between the two. So I feel like this is a nice developer experience. It reduces some of that boilerplate code. Okay, so we know that at this point in our execution that we have the linked page for this call to action. And so we can get its URL, and then we create our view model and we return that. And now the thing that we're returning, we can see here, it's a maybe of call to action view model. With the state of the content management system right now, we know that there will be a value in here. But at some point in the future, we want our code to execute fine, even if there isn't a value there. And the way we have this set up, there's not going to be any issues. So down here, when we create our home index view model, we populate the call to action with this call to action view model, a maybe of that type. And then we need to now finally use this thing, right? We've built up this data model that might or might not have values. How do we use it? Okay, so let's go over to our view. And we're going to come down here. And again, we have these similar checks. So we have model.calltoaction.hasValue. And if it does have a value, then we're going to pull the value out. And so this value property lets us directly access the value of that maybe. So it's kind of how we get it out of the container. This thing will throw an exception if the call to action is none instance, but we've checked here and we've made sure that it is not none. So we are safe to pull that value out. And so we now have our call to action and we can start rendering out values. And we do the same sort of check with our image. Does it have a value? If it does, we get the value property and we get the image. And then now we can render out the image. So these types of checks, they might feel not that great, especially if we're doing all this. We're adopting maybe so that we can get rid of these checks. There are options to get around that. Here's one of them. So maybe has a method on it called execute. And execute takes an action. So it's a void returning method or delegate. And that action will only be executed if the image has a value. So this render image method, we can come down here, and this is a razor, inline razor method. It will render out that image header if there actually was a value in this image maybe instance. So this is a nice way where we don't have to do the check. Again, we can let the maybe do the checking internally for us. Another option is to have a partial and pass our maybe image to the partial and then do the guard and the check in the partial. That cleans up this view a little bit. That might be a nice thing that a pattern that you might want to follow if you have lots of complex if conditions in your views and you want to get rid of those. Okay, so let's jump back to the slides.
Hey, Sean, got a quick question for you. Jeffrey Miller asked, what framework version is this available in and what's the namespace?
Gotcha. Yes. Okay, great question. Oh, and I should have mentioned this at the beginning. If anyone has any questions, feel free to interrupt me at any time. So maybe is not in the framework. It is being supplied by a library, and I'll jump over here. And this is the library that I am getting that maybe type from. This is a library I love. I use it in a lot of applications that I work on. I recommend people use it. I think it's a great introduction to functional programming concepts, specifically the maybe monad. And there's another one that this library has called result. This is what you would want to install. It is .NET Standard 2.0 compatible. So you can use this in .NET Framework, and you can use it in .NET Core and .NET 5 and .NET 6. It'll work everywhere. We can come down here and you can see there's an example of making nulls explicit with the maybe type. So this custom repository returns a maybe of customer. Actually, let me zoom in to make sure everyone can see. So it returns a maybe of customer, and then I want to check, does that customer, if there's no value, then I'm going to have some sort of error. And if there is a value, then I get access to the customer. So yeah, it's not in .NET Framework. It would be nice if it was. If you are familiar with F#, F# has an either type, or kind of like an option type baked into the language, into the not the framework, but yeah, it's in the language itself. And there's a lot of syntax around how F# works with pattern matching that makes using that option type, which is what they call maybe. There's lots of names for it. It makes working with it very ergonomic. Okay, so a quick comparison that I was mentioning, IEnumerable is a monad, and we should be able to see now that there's some comparisons we can make between maybe and IEnumerable. So they're both generic. They're both containers. IEnumerable of T represents 0 or more items. Maybe of T represents 0 or 1 items. Before I discovered the maybe as a monad, I actually would frequently use IEnumerable of T to represent 0 or 1 items. There'd be a lot of times where I wouldn't want to throw an exception. I'd want to say, if there was If there was something found, I would expect there to only be one, and I'd put it in the IEnumerable of t. And if there was nothing found, then the IEnumerable would be empty, and I treat those as two different cases. But there was nothing about IEnumerable of t that helped me limit it to just 0 or 1. Maybe does a great job at modeling that situation. And it works a lot like link. So these are direct parallels. Map for maybe is the same thing as select for IEnumerable. And bind for maybe is the exact same thing as select many for IEnumerable. So this parallel is not an accident. To be qualified as a maybe or a monad, a type has to have these operations on it. Or there's a set of them, and depending on, I guess, how long your functional programming goatee is, you might have disagreements about what needs to be there to effectively qualify it as a monad. But things you'll typically see are map and bind methods, and IEnumerable has those as select and select many. So what are the benefits of using a maybe monad to represent missing or optional data? Well, it moves the special case out of the model type. That's something I love. The null object pattern it's a great pattern, but it does dirty up that model with a whole bunch of machinery infrastructure to represent that state that you want to represent, and maybe moves it outside. And it's a lot like the null reference types, because null reference types puts it in the language, in the type itself, and maybe kind of, in a way, puts it in the type itself. It just changes that type to be a container of the data we're actually interested in. It's easy to map between types. So all we have to do is call that map method, and then we can map from one type to another. And we don't have to worry about transferring the maybiness, the emptiness of that data when we transfer from one type to another. And that's great, because it means we can continue chaining on all the operations that we want to perform on that data. And if at any point that data is not there, all those operations that we specify just won't be executed, but we get to be very declarative about the steps that we want to process on that data. So the empty, it flows across all the operations. You can kind of think about this as Super Mario Warp World. So when you blow on the warp whistle, or you go up to that warp world, you can run around in there and there's no bad guys, and you can do all the normal things that Mario can do, and you don't have to worry about whether you're going to be hit by a fireball until you go back down to the normal world. And the maybe monad is kind of like that. You lift your operations up into the world of maybe, you get to execute them, treat them like there's always something there. And it's not until the very end, when you go back down into the normal world of your code, that you need to check and see, was there actually a value that whole time? So when we get to the end and we need to actually display something, so think like an API controller where you're returning a JSON result. At that point, we need to figure out what we want that maybe to turn into. Is it going to turn into null on our JSON result? Is it going to turn into a default value? Or, at that point, we need to figure it out. But at any point before that, we don't. And same with rendering HTML with Razor. We really only need to unwrap that maybe at the very end when we get to Razor, because we need to produce some HTML at that point. So one nice thing about the maybe type is that you can represent a set of complex operations as expressions. So this is production code that we have in an app. And here we have subscriptions, which is an IEnumerable of some subscription type. We also have subscription order items, which is an IEnumerable of some order item type. And we are saying, get me the first one out of here where the order item has a subscription ID that matches the subscription being passed in here at the top. If I find one, then map that order item to its product name. If I didn't find one, well, none of this stuff is going to execute, so that's fine with me. If the value at the very end wasn't found, then unwrap it using this subscription plan's product ID. And this plan is also a maybe type. So here's a situation where there's lots of data that has optional or things that could be missing and nested properties, but I still want to work with it without having to do a bunch of checks all over the place. And using maybe lets me have this very fluent, expression-oriented way of processing data. Now, when you first look at this, you're going to say, I can't even read this. This makes no sense to me. This isn't even C#. And that's fair. When I was first learning LINQ, I would look at either the query syntax or Fluent syntax, and I'd say, I don't get it. I'd have to hover my mouse over the types and use Visual Studio to teach me what these things were doing. But eventually you get to a point where you type .where, .select, and you know that what's going to happen to the data that you're giving declarative operations to. And at the end, you don't have a whole bunch of checks, and you're okay with that because you trust that the LINQ operations do what they're supposed to do. And the same sort of thing happens with the maybe type. You start out with kind of procedural code, and then you move to using it more fluently, and then you end up just trusting the expressions that you've written and trusting that the C# types and that the compiler is intelligent and will give you the thing that you expect at the very end. And because maybe protects its data and doesn't allow you to get it out unless you explicitly say something like unwrap, you get to trust that, hey, at the very end, I know I have a product and nothing in here is going to throw a null reference exception if I correctly modeled and typed my my domain models with that maybe type where appropriate. Okay, but there's no silver bullet, so maybe has its own problems, and let's take a look at what those are. So developers might not be familiar with monads. However, I found that in a lot of cases with new types or patterns, you can kind of IntelliSense your way to victory in C#, which is nice. You know, you just kind of start using the thing and you hit dot and you look to see what methods are available and you try one out and you see how it works and what it returns and you continue from there. I've had success with this approach with both LINQ and with maybe. C# isn't functional first, so functional patterns don't always translate well. And we saw that in Razor. We still have to do those checks. It would be nice if we didn't. We still have to unwrap and get data out in a very imperative statement-oriented way. It's harder to debug with breakpoints when you're using the maybe type in the same way that it's harder to debug LINQ statements because they really aren't statements. They're typically expressions. You're chaining a whole bunch of expressions together and there isn't really a place to debug. You kind of need statements, a point in time where to land, where something has been finally evaluated to see what the state of the application is. However, what I found is that you just need to trust the expressions that you're writing, that they work how you expect. And the more you move away from some of the patterns that C# gives you out of the box with null and mutable data, if you move a bit away from those, then you start to be able to trust your expressions because you know that the type that you're using to represent the data makes sure that you're doing the right checks or working with the data in the right way at the right places. Also, if you have heavy branching, if-else conditions in your application and you need to do a bunch of different things in different cases, maybe might not be the best option, or maybe you should use it in more of a procedural way. All the chaining stuff, it can be hard to manage all those branches. You can still do it, and I've done it before. It looks a lot nicer in F#. In C#, it gets a little hairy. It can be hard to come back to and read it and figure out exactly what was going on. But that's because C# isn't functional first, so there's going to be some things that just don't translate well. So I'd say start using maybe in a demo app, in a little sample application in LINQPad. Start using it procedurally, and then adopt the more fluent expression-oriented approach as you become more comfortable with it. So that's my presentation. Thanks. If anyone has any questions, I'd be happy to answer them. Yeah.
All right. Thank you very much. I believe we did have one sort of a follow-up from Jeffrey Miller. He asked, does assigning null to a maybe of t convert implicitly to maybe of t dot none?
Yes, it does. Yes, it does. Especially, I would assume that any other implementations of it would do the same, but this library specifically does that. So that's a nice thing. It makes it ergonomic to bolt on maybe to an existing application that is using nulls to represent optional or missing data. You can pretty easily convert those nulls over without having to do a whole bunch of plumbing work.
Very cool. All right, guys, any last questions? Let's get them now.
So I have some links here. All of this presentation and this demo code came from some blog posts that I wrote. They're all here. If you just go to dev.to and then my name, you should be able to find them. So I touch on it a lot more in depth and with a lot more thought and analysis of the different ways of modeling this missing data with those approaches that we looked at.
Very cool. All right, everyone, last chance to register for the prize drawing. I just shared the link again. And as well, make sure to subscribe if you haven't. We can use every last one of your help to get to the 100 magic number that we need. Let me pull up over here. We'll give everyone another minute or two here to sign up. So once again, thank you, Son, for coming and presenting. This is actually a very interesting topic. I'm kind of excited now. I've got a project I've been working on, and we've had some hairy code that we've written a whole lot of ugly code to handle sort of situations like this. I'm almost tempted now tonight to jump right in and just create a new branch and throw this package on and start rewriting some of this stuff to see if we can't make it a little cleaner, because this looks exciting.
Yeah, it's a lot of fun to use. It's like kind of rediscovering programming again. It's given me a new excitement about working with C# and trying to write logic with lots of operations. There's another half of the maybe type, which I mentioned, the result type. That one's great as well. It kind of represents successful or failed operations. So you can combine maybe for missing or existing data, and then result for like database access or API calls. You combine those two together and you get this, you can end up with pretty 5-6 line long chains of expressions where you are guaranteed that those operations will not throw exceptions or fail at runtime. You basically remove null or exceptions from your application altogether.
Let's see, any other questions? I'm not seeing any. Let me scroll back, make sure I didn't miss any in the chat.
I'll make these slides available and post a link to them in the meetup.
All right. Yeah, that'll be exciting. All right, we had one mention from Ivan about desire to keep the streaming of the meetings even when we go back in person. And to let you know, that is the plan. We've started doing some research into what it takes to put on a in-person live event to stream. Doesn't look too complicated, so going to do a little Amazon shopping here probably in the next couple of weeks to pick up some capture cards and some better webcams and some other fun toys to wire everything up. And hopefully that's our plan, is once we get back to in-person real events, we're still going to stream, so that for those folks that can't come, or for people out of town that want to see our presentations, we'll have them available. So that'll be another thing to stay informed about. If anyone has any knowledge of that kind of stuff, I'd appreciate your input on those. That would be a very useful and happy thing for me to learn. I'm excited about the getting in. I always like learning new fun things, and this is definitely something like that, but it's definitely over my head, I feel, so I'll be glad to get any help I can to do it right. All right, I think at this point, let's go ahead and call it. We're going to go ahead and close the responses. So 5, 4, 3, 2, 1, and no more responses. Let me pull open the spreadsheet with all the registrations. All right. Hold on, let me not be mean. Here's our registration list. Oops, didn't mean to make that full screen. And we are just going to use good old random.org. So it looks like we got what, 1 through 19. Just remember, you do have to be present. So if you've left and we try to call out your name and you don't respond, you're not getting a prize. So Thomas Nielsen, are you still here? Can't view the chat list. Okay, maybe he's not here. Give him a minute. Give me a shout out if you're here, Thomas. You are our lucky prize winner of a JetBrains license. And we'll draw one more. I guess, even if you're not here, we'll still give you the prize. Then there's also some Couchbase items that are available. I'm not sure what they are. We'll get an email out to Matt Groves and he'll let you know. So let's see who else. Number 13. Sam Bilbrey. Are you here? Yes, Bueller. I will email both of you with your prize information and we'll be good to go. So, with that, once again, let's give another virtual round of applause for our presenter for educating us on the exciting world of monads with the maybe.
Thanks for having me.
Any last words before you go?
Nope.
No.
I've said all I need to say for the evening.
Okay. You're talked out.
Yep.
All right. We'll leave the stream going for just another minute or two for everyone to chat. And remember, we'll be at least one more virtual meeting next month. We're hoping, like I say, things are still in the works, but we're hoping September we can try to start getting back into in-person, but no guarantees exactly yet. But pay attention to Twitter, Facebook, Meetup. We'll let you know as soon as we have details on all that. So thank you very much, everyone, and see you next month.